Hello everyone, welcome back. In this Terraform Basics section, before we start creating our first Terraform scripts, I would like to show you the Terraform Registry page. Let's go to Google and search Terraform Registry. And you have to go to Terraform registry.terraform.io, click on that. And as you can see, this is a Terraform Registry page. And you can go and explore this. When you go below, you will see the featured providers, popular providers used with Terraform, including major cloud providers. You can see Kubernetes, Oracle Cloud Infrastructure, Alibaba Cloud, AWS, Google Cloud Platform, Azure. You can see that in this course, we are going to use the Google Cloud Platform from the Terraform registry page. You can see the modules. Modules are small reusable Terraform configurations that let you manage a group of related resources as if they were a single resource. So you can see the time they created and how many people downloaded. You can see the AWS provider and the Google provider. If you are new to Terraform, you can go and read more about it. And let's click the Google Cloud Platform since we are using this in our course. And when you click the Google provider, and you can here read the information which says lifecycle management of GCP resources, including compute engine, cloud storage, cloud SDK, cloud SQL, GKE, BigQuery, cloud functions, and more. This provider is collaboratively maintained by the Google Terraform team at Google and Terraform team at HashiCorp. And this page is basically, this Terraform registry page is provided by HashiCorp and Google. So you have to go to, you can see the use provider on the right side. Don't worry about it for now. I'm going to show it more in details in the next videos, but for now let's understand the page and explore the features. When you go to Google provider and go to the documentation, you will see all the Google Cloud features, services. You can see on the left section here, you can see from API gateways, you can see artifact registry, BigQuery, Google Cloud Bigtable, Cloud Compute, endpoints, Cloud Identity, Cloud Platform, everything, every service of the Google Cloud Platform available here. You can use it using Terraform. These are all the resource blocks. You can also here see the Google Cloud Platform provider, and you can see the Google provider. We are going to use this Google provider in the next videos when we start our first Terraform script. But for now, this just understand the page and the documentation. You can here, for example, create. You can, for example, here write compute. You can see Google Compute address, Google Compute backend service, Google Compute disk. Everything is available. You can also here search local. You can see it will show all the resources like HashiCorp local or local sensitive file, which we are going to deep dive in the next section. So you can also here click the browse and click on modules and explore the modules. You can see Terraform AWS modules and Terraform Google modules, Project Factory. You can also click here policy provider module, or you can also sign in with GitHub and explore the documentation from the GitHub. And you can also click this use Terraform Cloud for free. Thing you have to you have to create an account for that. We don't need it for this now, so basically we just need this Terraform registry page throughout this project. So this is, I think this is really easy to use, and throughout the whole project, throughout the course, I'm going to show you this, and I'm going to show you each Google Cloud service, and we'll explore all the resource blocks. Thank you very much, and see you in the next video. Hello everyone, welcome back. In this video, we are going to create our first local file resource block in Terraform For that, you have to go to Terraform Registry page, and you can see on the top there is a search bar, and you have to search local, and you will see this HashiCorp local. Click on that, and you have to go to the documentation, and when you go to documentation you will see the resources and data resources, and we are going to try these two resource blocks, local file and local sensitive file. Click the local file, and you can see the everything, the documentation, the information about this. You can see the notes, and you can see the example usage, which is resource local file. It's giving the resource name and the name, the foo, and it's giving the content, the argument content, and then the content and the file name, the path. So you have to read more about the argument reference. You can see that the following arguments are supported for this local file resource block. So it says this file name and content is, file name is required. Without this you cannot create it. So you can see more about the arguments. So without wasting time, let me go to Visual Studio Code, VS Code, Visual Studio Code, and let's create our first Terraform script, which is local file. You can see the Terraform. Before we jump on creating our Terraform script, let's go to the extension and enable one really good helpful extension. Let's write Terraform. Just write Terraform, and you will see the X2 extension. The first extension, as you can see, it's this extension is disabled globally by the user. Initially I used to use this extension, but after that, as you can see, this extension is disabled. But don't worry, you can use instead the HashiCorp Terraform, and you can just click the enable and start using this extension. You can see there's a lot of use cases and benefits of using this extension. It will give a lot of suggestions. So let's click the new, open a folder, and let me open my folder. I'm going to go to my folder. You can see I created TF script folder. You can also create folder and select a folder, and you can see that it's now uploading the TF script folder to my Visual Studio Code. And here you can see you can create a new file, or you can create a new folder. Let's create a new folder and name it local file. Local file, and inside this local file we can create a main.tf, which is a Terraform file. You can see the Terraform logo as well. Click enter, and inside this main.tf we will create our first resource, local resource block. For that, type resource, and when you click this resource, as you can see, it's giving me suggestions, and you can now write local file, and after you give the resource name local file, you have to give the new name. For example, example resource, and after that you have to specify the arguments. To specify the arguments, you can go to the Terraform Registry page, and you can see the local file, and on the right section you can see argument reference. Click on that, and you can see all the arguments. We need to mention the file name and then the content, or we can also give the sensitive content if we want to store in the file expects to be UTF-8 encoded string. And the differences between the content and sensitive content, that the sensitive content will not be displayed in the diffs. So let's write the file name, and let's give the file name, for example, example.txt, and then we need to mention the content. We can also, I'm gonna teach you really good the trick. You can click the Kelter, and after you press the Kelter, click shift, and you will see the arguments automatically. It will suggest you can see the file permission, the bands on for each ID, provider, source, module provisioner, warm, and everything. You can see the content even. So click on that, just remember Kelter and shift. And then after you give the content, you need to give the content, for example, let's say the master Terraform with GCP, which is Google Cloud Platform. And now our first resource, local file resource block is ready. We can go to terminal, new terminal, and we are in the TF script. And inside TF script, when you run the Terraform init, it will not work. Let me show you. Terraform, if you run Terraform init, it will not work. I will say why. You can see Terraform is initialized in empty directory, because in the TF script, there is no main.tf. You can see there is only local file, and inside the local file we have main.tf. So be careful. Just click cd, type cd, and then write the local file. And after you go to local file, let's go now Terraform. Let's do Terraform init. And now you can see it's initializing the backend, initializing the provider plugins. Basically, Terraform init will initialize. And you can see Terraform has been successfully initialized. You may now begin working with Terraform. Try running Terraform plan to see any changes that are required for your infrastructure. All Terraform commands should now work. So click, let's write the Terraform plan. So I have a typing error. Let's say plan. So you can see that the Terraform will perform the following actions. Local file .example resource will be created. It's showing everything that will be created. You can see the resource local file, example resource, the content. We can also mention directory permission. It's 0777 file permission, file name, ID. It says 1 to add, 0 to change, and 0 to destroy. So let's apply it. Terraform apply. And after you do Terraform apply, you have to enter a value. You should write yes. And as you can see, the applied is complete. Resource 1 added, 0 changed, 0 destroyed. And when you see the Terraform, you can see some files are created automatically from the Terraform. You can see the Terraform provider, Terraform log.hcl. You don't have to worry about these files for now. Just you can see the example.txt, and inside you can see the content, master Terraform with GCP. You can see the example.txt here, and you can see the content inside, and you can also see here terraform.tf state. So don't worry about it. So basically this will keep track of all the changes, stages. So our first resource block has been created, so we are done. So you saw that everything from the Terraform registry page. If you want, you can also provide for example here, the sensitive content, and you can also let's try the sensitive content and file permissions to set of the output file expressed as a string. In numeric rotation, default value is like 0777. Let's write the file permission, and again you can write file permission or click Alt Shift, and you will here see the suggestion file permission. And let's say not 0777, but let's say this is a default. Actually, you can see this 0777 is a default value. We can give another, for example 0770. Let's try this, and let's change the content from master Terraform from content to sensitive content. Let's change it, sensitive content, and let's do now. After you do the Terraform init, plan, and apply, you do not have to again plan or init. It will be really useful if you do plan, but you do not have to do Terraform init again. Let's write Terraform plan to see what actions. And it's saying the term Terraform is not recognized. I think I have a typo. Terraform plan. Yeah, I have a typo here. So you can see the argument is depreciated. It's giving me the warning. So you can see the file permission is changing, force replacement. You can see that the sensitive content, sensitive value, force replacement, and it's saying the local file example resource must be replaced with these. You can see it's underlined with red. One add, you can see 0 to change and 1 to destroy. And let's give it a try. Local Terraform apply and click yes, and it says the apply is complete. And here you can see the sensitive content is showing sensitive value. It's not showing the content because it's sensitive. So you can see here Terraform example.txt, and everything is complete. You can see the main.tf that we created, and you can also see the example.txt. So this is all for this video. In the next video we are going to work with multiple resources. Thank you very much, and see you in the next video. In the previous video we created one resource block, as you can see, local file. Now let's try to create multiple resources using Terraform. So for that I'm going to create a new folder inside my TF script. You can see we created already local file. Now let's create a new folder and say multiple resources. You can see the multiple resources folder we created. You can also copy this, or we can also, it is really simple, we can create a new main.tf, and inside this main.tf we can create a multiple resources. For that you just simply copy the main.tf everything, or if you are not lazy you can write it from scratch. Let's write resource and local file and give it name. For example, let's give it a name of let's say that learning tf, and give the file name argument, and let's say the tf.terraform, let's say terraform.txt. I always like think about what to give the name for the the file name or everything. Sometimes I stop, I'll seek, I will find really hard to find the name for the argument. So after we create the file name terraform.txt, you can give the content. Last time we used sensitive content, and we also used the content. For the content I will say I am learning Terraform. Let's say basics. I'm learning Terraform basics. And for last time we used only this resource, only one resource block, but for now we will use multiple resource. For that we can copy this, or I will teach you a really good extension, which is you have to simply just take this old resource and just press the shift and alt, and you have to click the down arrow, you can see, and then you will see the another resource block. It will copy it instead of just copying this like this kind of copying it and going here and then pasting it like this. There is a really good trick you can do, like shift alt, and then you have to click the down arrow, and you can see that it's copying now. So you can do it multiple times. You can see it's really easy and good trick, and I always use this. So in the next resource block we will use also the same local file, but we'll change it, for example, learning GCP, and we'll change the content. I'm learning Terraform, not Terraform, but here we say I'm learning Google Cloud Platform. Let's say GCP, And now, as you can see, we created two resource blocks, which is local file, which is the first one is let's change the file name to gcp.txt. And you can see that we have a second resource block, which is gcp.txt, and the content is I'm learning Google Cloud Platform GCP. And let's give it a try now. First, as you know, we need to change the folder. We are not in the local file now, we are in the multiple resource folder. For that, I'm going to go back and go to cd and say multiple resources, and you can simply say Terraform init and it will initialize. We have two resource blocks now. Let's say Terraform plan, and you will see the what actions will be created. You can see here Terraform will perform the following actions: one resource file, which is learning GCP, and learning TF. You can see both, and you can see here plan 2, not 1, because we have two resource blocks, and 0 to change and 0 to destroy. Now let's do Terraform apply and say yes, and you can see apply complete, resources 2 added, 0 changed, 0 destroyed. And if you go to multiple resources, and you can see here two files, text txts, GCP txt, you can see I'm learning Google Cloud. I have a typo here, Google Cloud Platform GCP, and you can see that there is also terraform.txt. I'm learning Terraform Basics. So we created two resource block, and this is one of the advantages of Terraform, that you can create multiple resources at the same time without wasting a lot of time. You know, it will be really, it's really, I think it's really good. So you can go to the documentation if you want, and go to the you can go to the documentation. For example, let's go to Google Cloud Platform, and let's go to documentation, and you can explore it more here. So in the next video, we are going to learn about the random provider. But before that, I forgot to mention one thing. Whenever you create everything, right? We created we just say Terraform init, Terraform plan, and Terraform applied. I forgot to mention Terraform destroy. When you do Terraform destroy, it will destroy all the resources and infrastructure. You can see it's saying that Terraform will perform the following actions, and you can see that the local file.learning.tf will be destroyed, and just click yes, and you can see the plan 0 to add and 0 to change and 1 to destroy, and let's click yes. As you can see, destroy complete, resources 1 destroyed. It's now destroyed everything. We have only left the gcp.txt. We destroyed the terraform.tf, as you can see. So let's do Terraform destroy again, and you have to confirm. You can see no object need to destroy it, everything is destroyed. So this is how you can destroy and create multiple resource blocks in Terraform. Thank you very much, and see you in the next video. In the previous video, we talked about the local file resources. As you can see, we worked with multiple resources. We created the local file and with the file name and content. So in this video, we are going to talk about the random integer. So when we go to the documentation to Terraform Registry, and in the top search bar, when we write the random, you will see the first one, the official HashiCorp random documentation. And when you click the documentation on the right top side, you will see all the information. And let's understand the basic information about the random provider. So random provider allows the use of randomness within the Terraform configurations. this is a logical provider, which means that it works entirely within Terraform's logic and it doesn't interact with any other services. So when we click these resources, you will see the random ID, integer, password, path, shuffle, string, random UUID. So we are going to practice these random integers in this video, random resources. So for that, let's go to our Visual Studio Code and let's go out from that and open the new folder, random integer. And inside this random integer, let's create main.tf and start creating our random resources. First and foremost, we are going to create a random integer. As you can see, random ID generates the resource, random ID generates random numbers that are intended to be used as a unique identifiers for other resources. So you can use the example, the random ID. We are not gonna gonna practice the random ID because, as you can see, you have to use it with some provider like a AWS instance or GCP instance or Azure instance. So let's go with random integer. So as you can see, the resource random integer generates random values from a given range, describing by min and max attributes for a given resource. So you can see the example usage. Let's take it from here, and you have to be careful that here min and max is a required attribute that we need to mention. Here, as you can see, the max is a maximum inclusive value of range, and min is a number, the minimum inclusive value of the range. So when you go here, example, you can take this, copy, and then let's go to the VS Code and paste it here, and let's delete the keepers. We don't need this argument for now. And let's specify the name, for example, random say int. Since it's integer, I'm gonna name it random int, and let's specify, for example, from 10 to 100 there will be random integer. And I didn't talk about the output. Let me show the output. To see the output of this random integer, we need to write the output, and as you can see, it's suggesting me here. When you click that, you have to give the name for this output. For example, let's say result1, and here you have to write the value. Okay, just write the value, and the value should be here from random integer, and we give the name random int, and we need to specify the result. All right, so now we can simply say we have to go to the folder first. Let's go cd random integer, and let's say Terraform init, and we will apply this, and you will see. Let's do Terraform plan and see the actions. You can see it. The last time we worked with the local file, but here it's working with the random integer.rand.it will be created. You can see the resource, and you can see here plan 1 to add, 0 to change, and 0 to destroy. So you can see the ID known after apply. Max is 100, minimum is 10, and result will be known after we apply it. Let's apply and click yes. And as you can see, the output is here. The result 1, 70. It's giving me the 70, the random, from between 10 to 100. So let's this is the way how you can use the random integer. So let's use the random resources. There is also random string. Let's use this. You can see the resource random string generates a random permutation of alphanumeric characters and optionally special characters. You can see the example. Let's copy this, and you can see the required argument is length. You have to use this, and we can also specify the keepers lower. You You can see the other arguments. So let's create the resource, and it will be random string, and let's give random str, and the required argument is length, and let's say 5. And let's give another argument here. Let's say we can also give the lower. By lower I mean that this is a boolean, include lowercase alphabet characters in the result, so default is true. Let's say we don't need the lowercase alphabet. Let's say lower false, because by default it's saying it's true. And let's also use the special. I say here the argument special boolean includes special characters in the result. These are, you can see, the special characters. So for example, in case of one project, we don't need these kind of special characters, right? So let's say special, and let's say special and say false, and let's give the output. You can copy this and click Shift Alt and the down arrow, and it will copy. And let's say this is the result 2, and the value would be random string, random string dot random str dot result. And when we run it, yes, and you can see, let me show you clearly. You can see the result 170. Result 2 is, you can see the uppercase alphabet and the number. So this is how you can create a random string. Let's apply the other resources in random provider. Let's use the password, and we can also use shuffle. Let's now use the password, and for that let me copy the password, and here after random string I'm gonna use random password. The required argument is the length, and we don't need this. Or you can also specify override special like this, but we need the length of, for example, 12, right? So we can also, for example, you can also make the numeric false. By numeric, it means you can go in here. Numeric is a boolean, include numeric characters in the result. Default value is true, so we don't need the numeric. Let's say special is true, and the length is 12. So let's give the output. The output is the result 3, and it will be, let's change the name. It will be random pass, and here let's specify it, random password dot random pass dot result, and let's apply this also. And it's, as you can see, it's a sensitive value. So in here it's saying you have to mention the sensitive to true, because it's a sensitive data, because it's a password. So you have to go to the output result 3, and here we need to mention the sensitive true. All right, so let's apply it again, and yes, and you can see that the result is showing sensitive because it's a sensitive data, and it's giving this error. So after you include this sensitive argument, it will be shown, but it will show only sensitive. So let's now create another resource from the random provider. Let's use the shuffle. So resource random shuffle generates a random permutation of a list of strings given as an argument. So let's copy this, and let's come here. After random password, we use the random shuffle. Let's give it random shuff name, and the input is necessary. You can see the input is required. You need to mention. You can see the West 1A. This is kind of the zones, right? So the result count will basically count you can read more about result count argument, the number of results to return. So let's specify the output here. This is the output 4, the last output, result 4, and let's change it here. Shuffle dot random shuffle dot result, and you can basically remove the sensitive to true. This only applies for the password. So now let's apply it again and say yes, and as you can see, it's showing the result 4. We have a US1D and US1A. You can see, let me show you, US1A and US1D. If you want to print all the inputs here, you can basically go and just remove the result count and apply. Let's apply it, and yes. And here, as you can see all the inputs here: US West, 1D, 1E, C, and A, the all. So this is the way how you can use the random provider. You can see random ID, integer, password. You can also use random path resource, and you can also use the random UUID. So in the next video, we are going to deep dive into other resources in Terraform. Thank you very much, and see you in the next video. Hello everyone, welcome back to another video. In this video, we are going to learn about Terraform input variables block. For that, I opened the Terraform official documentation, and you can see it's developer.hashicorp.com, Terraform language, values, and variables. And I don't want to spend a lot of time for reading the documentation. Instead, I want to do more hands-on. So let's read the main idea inside the input variables. So it's saying that input variables let you customize aspects of Terraform modules without altering the module's own source code. This functionality allows you to share modules across different Terraform configurations and making your module composable and reusable. So you can see some examples here they provided. You can see the variable, the type, the argument, and also here they provided the default argument. So you can see the default, type, description, validation, sensitive, and nullable. We'll mostly use the default, which is a default value which then makes the variable optional, and type is the argument specifies what value types are accepted for the variable. Yeah, you can, if you want, you can read more about the input variables in the documentation, but now I want to let's see it in action. So let's go to our Visual Studio Code, and as you know, we have a TF script, and let's create a new folder and say it input variables. Right inside these input variables, we'll create main.tf as usual, but now from now on we will start creating variables.tf as well, because we are learning variables now. So the first thing you have to do is just you can also copy the resource that we created. For example, local file, go to the main.tf, and as you remember, we created this local file resource block, and let's copy it and paste it inside the main.tf inside variables. And let's also copy another resource block from the random integer. It was actually random provider, I just confused it with random integer. So let's go to main.tf and let's copy this random shuffle because it has a list which is different from the string. As you can see, now we have only, as you can see, we have only in main.tf and variables.tf, and inside main.tf you can see two resource blocks. One is local file, another one is random shuffle. So basically we will change this input variables block by creating variables in this variables.tf. So let's create the file name, then the content, we don't need the sensitive content now, just content and permission and input. Let's create file name first. Let's create variable, enter, and give it name. So here you can give you the same name like file name. I don't want to confuse you, so I will give it a different name like file name, not the full name. It little bit different from the actual name. You can see f name, and here we need to specify the type and default, but you can also press click Ctrl and shift, it will give you suggestions. You can see it's default type. Let's start with the type. It's a string, as you know, and let's specify the default. It will be, the default is, you can see the example.txt. Let's copy it and paste it here, and we can also provide description if you want. Description, let's say, let me copy it from here, from my another window, and paste it. This path to the file that will be created. So if you want, you can provide this kind of description, but I don't want to include the description for now. It's optional. So we are done with the file name argument. Let's do the content and file permission. Let's copy that, and let's do the count instead of full content, and type would be the string, and the default, not the example.txt, but it should be the master Terraform with GCP. And we are done with the count as well. So let's do the file permission. Let's create the file permission variable, and here I will give it name. Let's say f perm, it's a permission, and let's write perms, which is permissions. So type would be the string, and the default is, as you remember, default is 0770. Actually default is, as you remember, it's 0777, but we change it. The default is 0777, not to confuse it. So the last variable is input here from the random shuffle, from the random provider. Let's do it. Here, let's give it name. Let's say input zones. You can see it's input zones, that's why I'm giving this name, and it will be not string. You can see it's the list here. This is list, so you need to be careful here. You have to specify the list, and here default, we just take this list, I just copy here and just paste it here, and now we are done with variables.tf. You can see we give each the different name and provide the type and default arguments. Now let's specify them here, the variables.tf. For that, you just need to write var.fname, as you name, this is a file name. And for the content, let's delete it and say var.count. And for file permission, as you remember, it was var.fperms, and the last but not the least is input, which was var.input zones, right? It didn't give me a suggestion. It was input zones, right? I think it's right. Yeah, we need to specify the output of this random provider, random shuffle. For that, you know how to create the output, right? We did it in the previous videos. So for that, just write the output, and then you have to give it name. Let's say result and zones output, and give the value would be random shuffle dot result. So we are done. As you can see, We created two resource blocks. One is local provider, the second one is random provider. And for the arguments, for each arguments, we provided variables. We created variables and we specified the type and default. Now let's go to cd and let's go to input variables, and let's do Terraform init. And I would like to show you one trick that I haven't showed you so far. This is Terraform, another Terraform command. It's Terraform validate. It will validate your code and shows whether your vote is success or wrong, or is there some errors. So for that, before you do any plan or before you apply, let's do plan first. Terraform plan. Okay, you can, before applying, you can do Terraform validate, or you can also even do Terraform validate before Terraform plan. You can see it's showing success, the configuration is valid. For example, if I just remove this result t and then do the Terraform validate, you will see an error, as you can see. So the Terraform validate basically validates your code whether there is no error. So let's do Terraform validate again, and you can see the success. And finally, we need to do Terraform apply and give it yes. And yes, you can see apply is complete. Resources 2 added, which is random local provider and random provider, and 0 change, 0 destroyed. You can see the list of zones, the US West 1 and etc. So this is how you can use the variables. This is a really simple example. In the next videos, we are going to deep dive into variables, and we are going to use these more in our projects. So thank you very much, and see you in the next videos. Hello everyone, welcome back to another video. In this video, we are going to talk about the other types of variables. As you remember that we practice it mostly with a string. Now I created types of variables folder, as you can see on the left, and I have two files, main.tf and variables.tf. And inside the main.tf, I have nothing but only the resource, local provider resource that we created earlier and practice it. And I have a variables.tf here, the name, the file name, and the content, master Terraform with GCP. So you can see the other types of variables: string, number, boolean, list, tuple, map, set, and object. And these are some of them. There are several types of variables, data types. So let's practice this in this video. Let's practice the number, list, map, tuple. So before we start, let's run this. Let's run Terraform init. Let's run the string first, so you can easily differentiate others. And say Terraform plan. I can also say Terraform validate. Let's apply it. You can see example.txt is created. We have a content of master Terraform with GCP. Now let's change the data type from string to number, and let's write the number, for example 2023, and let's apply it and say yes. And you can see the apply is complete. 1 resource is added, 0 changed, and 1 destroyed. So as you can see, the Terraform, one of the magics of Terraform is that the Terraform will first destroy, and then it will create. You can see the 2023. It first, like the Terraform first deleted the content string and then replaced it with a number. So let's copy this and let's comment this. So I have to mention how to comment in Terraform. It's really easy if you have experience. It's a piece of cake. So just press the Alt Shift A if you are using a Windows, There is another ways. You can also press the filter and question mark. This is another way of commenting, which I do this trick mostly. So I think in Mac it's the filter shift and A, filter shift and A, but it doesn't work with Windows. So in Windows, Alt Shift A. And let's use another data type. This is number. We have used the number, but let's use the boolean. Let's use boolean. Boolean has a true or false. Let's say true, and apply it. Yes, as you can see, it's showing true in example.txt. Let's copy this. Let's copy and then comment this, and we have another data type, which is, I guess, the list. Let's use the list, and let's use the list of let's say string. You can also use the number. Let's create a list. Let me write the cloud providers. 3 popular cloud providers: AWS, Azure, GCP. So let's print this. If we want to print, for example, the GCP, right? So we can come here, and here in the content, let's create an index, like a list, and the index of here is like this is a 0, and this is 1, and this is 2. It will start the counting from the 0. So if you want to create if we want to indicate the GCP, then we need to write the 2. All right, so let's apply it and say yes, and when we go to example.txt, you can see the GCP. And I think it's not really tough, so let's copy and move on to the next data type. Let's say it's the tuple. Let's write the tuple, and tuple basically consists of other data types. For example, mixing. Let's say the first string, and another one, let's say the number, and we have, let's say, the boolean. And inside this inside here, we can, for example, have to mention this each data type. We have a string first, and let's say hello world for this world, and for the number, let's say 2023. And for the bool, I think we can do this. We can do true. And now here we can, it's the same as the list. You can, for example, we can specify hello world by writing 0. Let's apply it. Yes, and now you can here see the hello world. If you want to print the number, you have to write the 1. If you want to print the boolean, you have to write the 2. The most importantly is not to forget that the index of this is it will start counting from 0. So let's use another data type. It's map. Let's copy this first, and let's comment this. Let's comment, and let's use the map. And for map, it's like a dictionary. You have to specify, for example, name, and for example, let's say age, and let's print it. You cannot specify it like list or tuple. You need to give it the name. For example, you need to specify the specific key. You can see it's a key and value. Let's specify the key name and print it. It will print my name, and let's go. And as you can see in example.txt, it's printing my name, so don't confuse it. you have to specify the each key. So these are some of the examples that I have showed you. If you want, you can go and to the documentation and practice the other types of variables with data types. You can see we have set, object, and other several data types. So thank you very much, and see you in the next videos. Hey everyone, welcome back. In this video we are going to learn about Terraform local variable block. And for that, I created the local variable block, as you can see here, and I have only main.tf. I haven't created variables.tf for that because I want to simplify it and make it clear for you. And as you can see, we have several resources, which is the local provider resources, and the same content like the question, how much do you love Terraform, and terraform.txt. I'm creating file name gcp.txt and ansible.txt. Before we start creating the locals, before we start using this local variable block, I'd like to show you the official documentation about the local values, as you can see from the developer.hashcorp.com. And when you search the locals, you see some information. It says that a local value assigns a name to an expression, so you can use the name multiple times within a module instead of repeating the same expression. If you are familiar with traditional programming languages, it can be useful to compare Terraform modules to a function definitions. Like it's saying that it's like similar to functions, so you can use it over and over to avoid some repetition. So let's use it in action. You can see how to use locals here. You can see slightly different from the variable. You can see we are not gonna use with any cloud provider since we are doing some basic Terraform stuff. So I created, as I told you, I created the 3 resources, local provider resources, and like here, for example, we are repeating like how much do you love, right? The same, how much do you love GCP, how much do you love Ansible. I'm gonna give a very simple example to not to repeat, for example, this how much do you love. Let's create the locals here. Let's create locals, and inside these locals, let's give it the name, for example, content question. Let's say content question, and give this question like how much do you love. Copy and paste it here. So we created locals, and inside the locals we have a content question, right? This is content and the question. So we are writing how much do you love. The same thing here, you can see it over and over repeating. So how can we use the locals here? So it's really easy. You can just delete this how much do you love, and you have to write the $sign and open, and here you have to simply say local dot content question. Same, just copy this and paste it here. How much do you love? Same here in Ansible. As you can see, we are using the locals content question. So this is only one example. I know it's not really a good example, but it's really simple, so you can understand it clearly and apply it for your future projects. So let's give it a try. Let's do Terraform init. We are inside the types of variables. We need to go back, cd, and we need to go to cd local variable block, and let's do Terraform init, and let's do Terraform plan, and let's apply it. Yes. Now as you can see, it's created 3 local provided resources here. Let me show you. Here you can see the local variable block folder, and we have, as you can see, we have a terraform.txt which says how much do you love Terraform, and we have a gcp.txt, how much do you love GCP, and we have ansible.txt, we have the content is how much do you love Ansible. For example, if you change this, for example, let's say, do you like Terraform, do you like GCP, do you like for example Ansible? Let's apply it. Let's change the content, apply, and give it yes. And it's, as you can see, it's destroying all the things that the Terraform created earlier, and it's creating again with a new content. You can see, if we move on now, you can see, do you like Ansible, and do you like, for example, GCP or the Terraform, do you like Terraform? So it's really easy. So you can use these locals in this way, and this is the really simple and basic example, so you can understand it clearly. And I hope it was really clear, and you can apply these the locals in your future projects. Thank you very much, and see you in the next video. Hello everyone, welcome back. In this video I'm going to explain you implicit and explicit dependencies in Terraform. As you can see, implicit dependency is like their name suggests, they're automatically detected by Terraform. It helps Terraform to know in what order the resources must be created and deleted. Whereas the explicit dependencies are dependencies that are set up manually between resources using the depends on keyword. So let's see it in action. I'm going to go to my Visual Studio Code, and here you can see I created several resources and resource blocks. You can see random provider, and here we have the local provider, and you can see the implicit dependency and explicit dependency. So I created random integer between 100 and 1000 here, and I'm here creating a local file and writing the file name implicit.txt. Let's start with implicit dependency. Let's give it the content. Let's say this is random number, and from random integer. And how can we use implicit dependency? It's really easy. You just need to write the $, and then inside you need to specify resource name and the custom name. Let's say random integer dot rand int dot id. You also have to specify the id, otherwise it will give you an error, so be careful. And it's same with the explicit dependency. Let's give it the same content, but only thing we need to change is number. This is a random string, so it will give an ID. This is random ID, so we need to change the resource name here. It's the random string, and dot rand str dot id from the random string. And as you know, as I explained it, that in explicit dependency we need to use the depends on keyword. Let's use it, depends on, and inside depends on keyword we need to specify the resource name and the custom name. This is a random string and random str. So we are done. As you can see, they're almost same. The only thing in explicit dependency we are using the depends on keyword. So let's see it. Let me do Terraform init, and we will see the result. You will see the two files, implicit.txt and explicit.txt, and inside you will see this content, random ID and random number. Let's plan it, and finally let's apply. As you can see, it's created four resources and 0 changed, 0 destroyed. Let's see here. Here you can see implicit.txt and explicit.txt created. So let's start checking implicit.txt. You can see this is a random number 938 from random integer, and here let's check the explicit.txt. This is a random ID. You can see the ID here from random string, because here I specified the length 25, so you can change the length if you want. And this is how you can use the implicit and explicit dependencies. I think these are really easy to understand and to use. So thank you very much, and see you in the next videos. Hello everyone, welcome back. In this video we are going to learn about lifecycle rules in Terraform. As you can see, we have 3 lifecycle rules: create before destroy, prevent destroy, and ignore changes. Basically, create before destroy, what it does, it create the resources first and then destroy it older. By default, Terraform will destroy the resources first and then create the new one. But here, if we apply this lifecycle rule, the rule will create the resources first and then destroy the older. The second, the rule is prevent destroy. If you apply this rule, you cannot destroy the resources. And the last rule is ignore changes. If you apply ignore changes, and for example, if you include the specific attributes of, for example, the local provider or random integer attributes, for example min or max, it will not apply, it will just ignore. So let's see the official documentation also. If you go to developer.hashicorp.com, you will see the lifecycle here inside the meta arguments, and you can read about more information in the documentation. It gives a lot of examples. You can see syntax and arguments, create before destroy, and saying by default when Terraform must change a resource argument that cannot be updated in place due to remote API limitations, Terraform will instead destroy the existing object and then create new replacement object with the new configured arguments. Very well explained. You can read more about for each lifecycle rule, and you can see the examples. So let's do it in action. So I created lifecycle rules folder. Inside I have main.tf, and I have a random provider, which is random integer from 1 to 40, and I'm also showing the output. Let's run it. Let's do Terraform init, and we will see the default Terraform action. Let's plan it and let's apply. Yes, it's only showing now creating, because if we change, for example, let's say from 10 to 40, right, or from 10 to 50, let's say, and if we apply it again, and if you do yes, as you can see, the Terraform is first destroying the resources and then creating the new one. So what if we apply the lifecycle rule, create before destroy? Let's do it true. You have to specify this lifecycle inside the resource, not the outside. You can see the name one is 24, the output. So let's change the from, let's say from 50 to 200, and then let's apply it and say yes. Now you can see that our lifecycle rule is working. The Terraform is first creating the ID 159, you can see, and now it's destroying the older one, which was 24. This is how the create before destroy lifecycle rule works. So let's comment it, and let's use another one. Let's see another lifecycle rule, which is prevent destroy. If you make a true, and if you want to delete the resource, if you want to do the Terraform destroy, for example, Terraform destroy, you cannot do it, because as you can see it's saying instance cannot be destroyed because resources random integer dot rand int has lifecycle prevent destroy set, but the plans call for this resource to be destroyed. So you cannot delete it, you cannot destroy it, because we are using the lifecycle rule prevent destroy. But if you comment it, let's say if you comment it and do Terraform destroy, you can do it. As you see, if I do yes, it will destroy, but I'm not do that. We will have to see another lifecycle rule, which is ignore changes. And for example, when you apply ignore changes lifecycle rule, you need to specify the resource attributes. For example, let's say let's change this to 20 and this one is 100, and let's ignore the min and let's apply it and do yes. As you can see, it's destroying the 159 and it's creating the new, but at the same time it's ignoring the min, the 20, right? So if we also include the max also, and if we change this to 22 or 1, let's change the values and then apply it again, Terraform apply. Says no changes, your infrastructure matches the configuration. We didn't change anything. We changed it actually, but it's ignoring the min and max. I think you got what I mean, right? It's where let me show it again. Let's change it for the values and then apply it. As you can see, it's not just it's just ignoring our the attributes, because we are using lifecycle rule. For example, if we just comment it and then if we do Terraform apply, and you can see that it's now working because we just commented the lifecycle rule. And now if I do yes, you can see the name 1 has a 24 lifecycle rule. So this is all about it. Thank you very much and see you in the next videos.